So yesterday we have learned about various activation functions are used in between your sigmoid is there, softmax is there, rectified linear unit is there, leaky redo is there, and binary class classification user loss function of binary cross entropy and categorical cross entropy is the loss function for multi-class classification. Now it will be important to discuss about first what are these different activation functions and how they play an important role in giving us the desired label. Okay, let's go ahead. Linear or identity activation function, which takes input and it multiplies by the weight of every neuron, takes the input data, which multiplies by the weights of each neuron and creates the output signal proportional to the input data. This is the first and the basic activation function. Usually, it is used as in the output layer of regression. This is used as an output layer of regression. How our output will appear? It looks like f of x equals to x. Okay, where x is your sum of input. You can also write it like this: f of g of x, which is equals to g of x. Now this ranges from minus infinity to plus infinity value. So as you observe here, our value will range from minus infinity to plus infinity. Pros. It gives a range of activations. So it is not a binary activation function. It is a regression one because of the range. This gives you the range from minus infinity to plus infinity. There is a terminology called as backpropagation in terms of neural network. What happens in the backpropagation is that we take a derivative value of the error, like partial derivation of the error with respect to its weight, and we backpropagate it to the previous layer. We just give it a back feedback to minimize the existing value. So the derivative of the function here becomes a constant value and it has got no relation to the input x. It's not possible to go back and understand which weights in the input neuron can provide a better prediction. Backpropagation is not possible because if you will see that in place of output we are having a constant value, and for a constant if I'll take a derivative I'll get a 1. It's like taking d of x upon like dx. When you take it, we get a 1 value. That's the reason why the partial derivation or wherever the neural network have got backpropagation, this is not recommended to use in the output layer. So in the likes of your leaky redo, sorry, in the likes of your uh, algorithms like recurrent neural network, which is totally dependent upon the concept of backpropagation, this will be not recommended to apply. Next, unit step function. In case of the unit step function, we are talking about a value 0 and a value 1. Basically, unit step function provides you binary class classification. This is used for binary classification. Only two results are possible in this. And how these two results will be divided, it will be divided on a threshold limit. Again, you can assume that here your f of g of x, where g of x is your sum of input to the neuron, right? Yesterday we talked about it. This is your sum of input, or in fact, sum of weighted input. Weights are also there. Sum of weighted input is given by f of g of x. Now, this f of g of x will give you two results. It will give you a when your value is when your threshold value is, that is g of x is a smaller than c. Let's say I'm assuming that it is c as the threshold value, and you will get a b if your g of x is greater than equals to c. You can replace a by 0 and b by 1. So this is how it works with my unit step function. Okay, I'm hoping that you are understanding them. So sigmoid function. Sigmoid function gives a shaped curve. In order to now where it is used, like this is used in binary class classification. This one is your output layer for the regression algorithm. The linear or identity activation function is used in regression output layer. This is used in binary class classification output layer, binary class classification, and also this is used in one of the very popular algorithm which is known as LSTM, long short term memory. This is also used in LSTM output layer and input layer, and this is very much used in binary class classification output layer. Now, how does sigmoid works? I'll explain you in a minute in our explanation part, but remember where it is used. Now, this is a non-linear representation of your data. This is non-linear equation. Hence, this will be differentiable at all the point. This means that you can find what is the meaning of differentiation, that you can find the slope of the sigmoid curve at any 2 points. In this case, the output will range from between 0 to 1, and basically it gives you the output as a probability value. What you get from this is that prediction, we get a prediction in the probabilistic form, and here the prediction will be between 0 and 1. Prediction in probabilistic form will be either 0 between 0 and 1. So we get our output between this range, which is given by 0 to 1. Here the output is not zero centered. This is computationally little expensive. These are the cons. But yes, this can be used. The problem here was the problem of linear or identity activation function is not applied here, because this can be applied to the algorithm which gets back, which updates its error value by backpropagation. So because it is differentiable at all the points, so can be applied in neural network where backpropagation is needed, which is like recurrent neural network or etc. Something like that. Hyperbolic tangent. Now this is not used as a binary class classification, or neither this is used as an output layer. This is used in the input layer. This is used in input layer activation function. Input layer activation function, which is given by something like this. Why it is used? Where it is used? To give the weightage, to provide the weightage to the input data, and the weightage range from -1 to +1. We have a range which goes from -1 to +1. This is not used in binary class classification. Remember that. This is used to give weightage. So mostly it is used. This is used in the input layer of activation function. Example will be which algorithm? LSTM. In LSTM, it can be used. Next, rectified linear unit. Rectified linear unit, in that we take max of 0 comma x. That is, we go with maximum value that starts from a 0 value, and here we'll have a g of x. It starts from 0 and it goes all the way till g of x. What is g of x giving me? G of x provides me the sum of input. Okay. When way it will be compared, either you will get a 0 as an output or you will get g of x as an output. Let's see. 0. If your sum of input is a negative, and you will get a positive value, that is g of x, when your g of x is greater than equals to 0. That's why you can see that for a value lower than 0, or for value which is lower than negative value, it is all 0 here. Okay, so rectified linear unit gives you the output which goes from 0 to g of x. G of x will be your sum of value. So we will see that if your sum of value comes out to be negative, it will give you 0. Otherwise, it will give you that particular value. Okay. This looks like that it is a linear equation, but it is non-linear. And ReLU is again differentiable at all the points except on this particular portion. On the negative portion, it is non-differentiable, and on the positive side, it will be differentiable. It allows, why it is used, because it will always give you a positive value and it is fast. That's why this is one of those favorite neural network algorithms which are used. Okay, because it gives you always a positive value for the neural network to converge properly and fast as well. Okay, so yeah, that's how things work here, as you can observe. Next, the problem of ReLU is made better. Again, this is one of those where it is used in the input layers of an input and hidden layer of neural network. In the input and hidden layer of a neural network, rectified linear unit is used. Similarly, 10H is also used in the input layer or hidden layer. Sigmoid only output layer. Unit step function only output layer. Linear or identity function only output layer. Last and leaky ReLU, we have understood that this will be again used in the input and hidden layers. Wherever there is a requirement to have, wherever you see there is a small slope or a small update, just to make your negative side also alive and differentiable, we have got a small update on the negative part, which is 0.01x. This is a small update, 0.01 of g of x. This is the small update that we have. This prevents a dying ReLU problem. This variation of a ReLU has a small positive slope in the negative area, so it does enable backpropagation even for the negative input value. We have got backpropagation for both. We've got backpropagation for both the value, and yeah, this is how it is used. Softmax. Softmax function calculates the probability distributions. That means we'll be having multiple values of the output value here, as you can observe. Let's go through it. 1, 2, and 3. These are, let's say, my neurons for my output layer. This is my output layer neuron. Once we have got here my output neurons, let's say we are having three values, we will be expecting to get outputs like 0, 1, and 2. These are my three classes. When we apply on these softmax, it will give you the responses as 0 point in distributed probability form. That means for all the results, it will try to give you some probability value. But for the for one of them, it will be high, and for others, it will be very very small. Let's say the predicted output is 1, class 1. So for others, it will be like, let's say, 0.05, this will be 0.9, and this will be 0.05. Like that, it will be distributed. In fact, even for, it will be distributed very, less very, yeah, the magnitude will be very less. Let's say 0.001, like that, that type of value it will be coming up. Something like 0.01, 0.01. And rest of the value will be given to the actual predicted outputs. As you observe in this case, it will be coming out to be 0.998, like that. Okay, so this is how the things work in softmax case. And as I have already explained you, softmax is only used for multi-class classification. And of course, this is again used for the output layer. Clear? Any questions anybody have? Any questions anybody have? Okay, so these were the key elements about the seven type of activation functions which are popularly used to develop your neural network algorithms. Hope you have understood them. Now let's move ahead to our whiteboard and let's explain you the things. Okay, so how exactly the binary class classification works? In order to do that, you need to understand our equation, which is basically the sigmoid equation. And the sigmoid equation is given by what? Mathematically, sigmoid is given by, is represented by, in fact, you can say, is represented by probability for y equals to 1 for the given value of x is given by 1 upon 1 plus e to the power minus z. We have got 1 upon 1 plus e to the power minus z value. Here z is given by beta naught plus beta 1 into x. Now this equation is called as your sigmoid equation or sigmoid function, which is non-linear form of non-linear form. Okay, so what exactly the equation represents here? It represents the probability for the, so this gives probability of success. What is success here? Class 1. Now from this we will get two results. Now how does it is represented? It is represented in an S-shaped curve form. This is represented as S-shaped curve. This is how your S-shaped curve will be represented. Let's have our results. My two classes, one, two, three, four, five. Let's imagine this belongs to class 0. Sorry, class 1. This belongs to class 0. Got here y equals to 1. Got here y equals to 0. And let's take the distribution. This is how it is represented. Okay. Or let me make it much more better. This is how it will be represented. Okay. This particular curve is known as your probabilistic curve. Remember that at every line, at every point here, this is representing nothing but is representing here probability of y equals to 1. Let's say y equals to 1 here indicates in terms of images x will be features of images, and y equals to 1 will be given by, let's say this is a dog and this one is a cat. Two images are there, dog and cat. Now when you apply onto all these different data sets, what we will get, we will be getting here probability y equals to 1. So for y equals to 1, for the given value of x, it will be represented like this. So at every given point, it is basically will give you the probability value for y equals to 1. Okay. For every given value of x, which is a feature of that particular image, we'll be getting some probability value. Let's say this is coming out to be 0.3. This is coming out to be 0. This is coming out to be 0.3. This is coming out to be say 0.4, and so on. How classification take place? Okay, we understood that it will be giving you the output in a probabilistic form, but how from the probability, our classification, we will be getting the output as 0 and 1. So how classification, when we say that we need to have a classification result, I mean that we should get a 1 or 0 value. So yeah, let's try to understand it. Same again, same thing. We'll be having a probabilistic curve, and we'll have class 0, and we'll have class 1, and your sigmoid will be giving you the output in a probabilistic curve, which will be represented somehow like this. Now at this given point, we'll have something like 0.5, which is a threshold value. For the given threshold, we'll have 2 points. Probability for y equals to 1 for the given value of x. This will be greater than 0.5, and due to that your output will be 1, and probability for y equals to 1 for the given value of x, this will be smaller than 0.5, and the output will be equals to 1. Sorry, output will be equals to 0. So these are your two possible things. One will be either a 1 value and the other is a 0 value. These are the two possible outcomes, 1 or 0. This is how it works. Okay, any questions? Now let's talk about the error value here. If there are no questions, let's talk about the error equations. Error in classification. So, in case of regression, we know that the error will be given by the difference in the actual value and the predicted value. Here in error, here error is measured by cross entropy function. Classification uses entropy. It measures degree of randomness or impurity here, impurity in the class. How this will work like this. We start with my x value and we have the y value here. What is the error it actually represents? Let's imagine that these are all my class 1 and these are all my label 0. Let's perform the binary class classification. And here we go with my binary class classification again. The reds are representing your class 0. These are all your misclassification value. What is misclassification? Misclassification is a terminology for where your y actual is not equals to y predicted. That means your algorithm is not able to predict accurately your actual y value. How do we measure it? We measure it by term something called as cross entropy. What is cross entropy? So your usual entropy is used to measure your randomness and impurity in the data, which is given by E entropy equals to minus of P log base 2 P. Here first is your expected probability. This is expected probability value, and second P is your predicted. Again, it is probability only, but it is predicted one. So first one is your expected, the second one is your predicted. We measure it like this. Entropy is given by minus of y log base 2 p. This is for class, or this is for y equals to 1 when your actual class is 1 or your neighbor is 1. When your neighbor is 1, it is given by this 1 minus y log base 2 1 minus p. That's basically given by label 0. When your label is 0, then the output is given by something like this as you observe minus of y log base 2 1 minus p. Combine them and you will get that terminology cross entropy. Because why it is called as cross entropy? Because if you will plot them, the curve crosses each other. Okay. If you will see here, basically there are two equations, one for the label 1, one for the label 0. This one is for label 1 and this one is for label 0. This is for label 0. This is for label 1. Okay. Now let's take your error equation, which is also known as log loss, or this is also known as your cross entropy value. This will be given by minus of y log base 2 p minus of 1 minus y log base 2 1 minus p. That's my two equations. Okay, combine them. Okay, any questions? Seems to be like any. So we are done here with the discussion of how a neural network will perform its classification. Now let's, in order to work on TensorFlow, we have to install it. Go to your command prompt or Anaconda prompt, wherever, like just like the way you have installed OpenCV, similar to that you have to do here. Just like the way you have installed it for OpenCV, similar to that. Go to the command prompt and start your command prompt. As I said again, I'm repeating that without installation it will not work. So you need to first install command prompt window, and here we will be writing simply pip install TensorFlow. So for me it is already satisfied because I've already installed it. But for you it will be asking you to install it properly. Remember, pip install TensorFlow is has to be done in the similar way as you all have performed the installation step of OpenCV. And once you are done, you can start Jupyter Notebook and test it by importing TensorFlow there. Simple import TensorFlow on a new Jupyter Notebook. You can begin, and we will discuss the further things on the Jupyter only. You can do this task on Colab for a temporary basis, but for the larger picture, we will require again the webcam, and webcam is not accessible through your Colab. So that's the reason we have to install it locally. And to install it, you need to follow the process that I just explained you. That open either the command prompt as an administrator or your Anaconda prompt window as an administrator and write the simple command of pip install TensorFlow. Okay, anyway, I'm waiting for your confirmations. It will not take more than 5 minutes, I guess. Uh, Once the installation is done, please remember you need to install it just like the way you have installed your OpenCV package, similar to that. Please also make sure that you finish downloading face expression and face mask or zip file as well. These two files, please install. There is no error. It is an installation and run it as an administrator. It will be installed. Just follow the instruction. Open your command prompt window or your Anaconda prompt, just like the way you have installed the OpenCV, similar to that. Well, if it worked for Anaconda prompt, use Anaconda. If it worked for normal prompt, then use normal prompt. For me, because I have installed Anaconda as an administrator, I can install it from CMD and it will be reflected in the Anaconda. So yeah, just open your Anaconda prompt or like Anaconda PowerShell prompt, or you can also try out on your normal CMD window. And in that, you should be run as an administrator first of all. And you have to write here pip install TensorFlow. This will take some 5-10 minutes and it will be installed. For me, it is saying that it requirement is already satisfied. TensorFlow is basically a deep learning package driven by your import TensorFlow STF. Tensor. What exactly is the meaning of tensor? This is n-dimensional representation of an array of data for various ranks like scalar, which is tensor rank 0 or tensor 0. Then we go ahead with my vector, which is given by tensor 1, matrix is given by tensor 2, or just say that rank 2. We have got rank 1 here, matrix, and then the last, there is higher dimensionality, are called as simple tensors. This is more than 2, 3 rank or more, given by that particular value. Scalar with tensor rank equals to 0. Tf dot constant, sigma value 10, and it will be returning me shape as nothing. Why? Because this is a simple constant value with a 0 rank, so shape returns nothing. The default data type is integer 32 bit, 32 byte in fact. That's the maximum goes to 64 bit. This is your 32 bit value, which is default value. You can reduce it as per the value that you are providing here. So we provided here rank 0 with tf dot constant 10. Next, let's go ahead with my tf dot constant 128 value. If you take here, or let's say 127 value, if we take that, we'll have a D type which will be given by int8. What is this 127 indicates here? This indicates a scalar value, scalar with tensor rank equals to 0, and data type is equals to integer 8 bit. And if you will go with integer 8 bit, you will see that the maximum range that it is taking is 127. That means it will start from 128 minus 128 to plus 127. That's how the values ranges. Let me share these codes on again the snipper. A new snipper we will start. So here we will have, let's say I'll start with deep learning, and this is my topics of TensorFlow. Now, how we are supposed to share the URL? This is a local machine, right? The Google Colab is URL, TensorFlow and Keras. Let me share the line by line code here, and you all can copy it from this definition of tensor. Yes, participants, drop yes in the chat if you're finished. Okay, so you can see that we have changed here the data type to 8-bit. Remember that if you will be changing it to 8-bit, the range it can take is from minus 128 to plus 127. Similarly, we can have some more constant value. Let's pick here my constant value 1 is equals to tf dot constant, and let's put up here my number, which is 12768. My d type will be 16 here, and this is my scalar value, scalar with tensor rank equals to 0, and we are talking about here integer 16, which will basically mean that it will go for 2 to the power 15. 2 to the power 15 will be 32768, is in minus 2 plus 32767. It goes from minus to this particular range. If your number is exceeding this range, then you have to use 32. So basically, within the range, it's okay, but beyond the range, you have to then change this data type, D type, in fact. Next, how about if I have saved here the value in this constant variable, and if I wanted to access the value, just the value, so I'll write here dot .npy. It will return me only the numerical term. Constant one dot shape, which will return me the shape that's again coming out to be an empty shape here. Vectors. Let's pick here my vectors here. Tensor rank equals to 1. This includes dimensionality equals to 1. Let's start with my constant 2. Will be equals to TensorFlow dot constant, and we start with a value 20, 30, 40, 50, 60, 70. You can have some more numbers here, 15 point. These are all my floating terms. Let's keep my D type as float 16. Floating term does not start from float 8. Print constant 2, and it returns me the result like this. Let me keep on adding everything here. This is about vector. Now that's what I was telling you earlier as well, that all the features are represented in a individual vector. This is how a vector shape will look like. It will mean that they will be all represented in a one rank value. Your images are always represented in RGB form, isn't it? So if you will read an image data, it will be basically read as an array, which I have already discussed in my NumPy. And if I'll try to read it again here in the similar way, and I can convert them into an array as well, because this particular value can take array as well, NumPy array. Okay. So suppose I wanted to read an image data. Okay, if you remember, we have discussed that in my Google Colab, the NumPy one, which we discussed recently. So in that, we will try to read an image data, and if you will try to read an image data, it will be read as an NumPy array, and that NumPy array we can pass it to the value which will basically represented as a vector here. Okay, so we do have the CV2, isn't it? So import CV2, and I have to use here cv2.im read. And if I'll read here any image, let's say my image is available in under E OpenCV, and I'll take here let's say pizza pizza.jpg. If I'll try to read it, these are all represented as a NumPy array. Let me save it as an image array, correct? But these NumPy array here that you observe, this is a three-dimensional data, right? If in this case, if this NumPy array, let's say the data type, if I'll check, what is the type of this? This is a NumPy ND array. So to that, if I'll apply the method of revel, remember revel is used to convert your multidimensional array into a 1D array. Now this 1D array is called as vector, but if I'll keep it into the original form, then this is an n-dimensional tensor. This is an n-dimensional tensor, okay? So this is what I wanted to discuss basically, that there is a difference between your image data and the array revel, which is a 1D value. Now this is a one-dimensional data. Can we pass it into this and create a constant value? So yeah, we can do that. tf dot constant, and we can pass here revel value, and if you will execute it, this will become your tensor. Okay, so what did we did? We just read an image data, and always remember that image data when you will read it will be represented as an NumPy array. Revel function converts your n-dimensional array into a 1D array. This is a one-dimensional array, and now that revel value we have passed directly to tf.constant to create something like this. So there are near about this much value or entries in it, and these are all your color value. Okay, cool enough. Let me share you this whole line. The dataset's location will differ, so please try to read it accordingly. You have already read it multiple times for different examples, so I'll expect you that you all remember it. Okay. Once you are done, you can tell me in the chat that you completed it. Everyone, drop a yes in the chat if you finished till here. Okay, now I'm moving to the next part, which is my TensorFlow metrics. Constant for tf dot constant. Okay, we got here my dot numpy file, and from the numpy we are getting that as a metrics value. Okay, similarly we can create now metrics means what is the shape here? Shape will be the deciding factor. Remember, shape is 2. This means this is rank equals to 2. This is tensor rank. Let's build an ND array now. Tensor and dimensional array. We'll start by constant 4 equals to, sorry, constant 5. Tf dot constant, we'll start by taking here all these values 20, 30, 40, 120, 130, 140, 200, 300, 400, and all these values. This will be represented as constant 5, and we will be getting my results. Now, this is my matrix value. Okay, we got here my tensors. Now you can see that what is the shape indicates here. Shape indicates how many such matrices are there, and what is the shape of the individual matrix, which is coming out to be 3 cross 3. Okay, so these are my various variables that you can declare. Now we will talk about some of the mathematical operations and how. Okay, one more thing. Just like the way we have declared the constant value. Now, constant will not update over the period of time. And if you wanted to have the variable in place of that, then variable can be updated here. Okay. If you will take a variable means it can get updated, but the constant value will never get updated over a period of time. This is my first variable. So we can just say that it is variable 1. And yeah, this is how you can declare a variable as well. Hello, sorry, my mic was muted. Now you are able to hear me. So basically, we are trying to perform this simple equation. Remember, we have written everywhere our neural network equation. It was written as y equals to wt plus wt multiplied by x plus bias value. Here my weights are given by tf dot variable. And this is how my values will appear. In this we have the data type which is given by float 16 of 16 byte, sorry, 16 bit size. Print weights is given by your shape 7 cross 1. That's my weights. Let's take my features. X equals to tf dot variable. Let's take the variables again. We are taking up here the numbers again. We'll start with my values, which starts with 8. Let's take the shape here. The shape is coming out to be 7 value. 1, 2, 3, 4. Now this will be given by x, and the previous one is given by your weights. Now let's perform here y equals to wt multiplied by x. TensorFlow dot, let's do the tensor dot product with weights and feature x value. With x is equals to 1, we get my output as an error. Why we are getting the error? Because here both the matrices are of similar shape, and basic this is violating the rule of basic mathematical operations that could be performed. Right? Multiplication between two matrices can only be applied if the number of row is equals to the number of row of one matrix is equals to the number of columns for the second matrix. We start with my wt is given by tf dot tensor dot. We provide here my weights. Then we do here my tf dot tensor dot with wt multiplied with x. Now it will work. Yeah. Okay, 1 second. What happened here? Missing two arguments. wt, what's going on, wt multiplied by x is equals to 1. This is weights. Okay, this should be transpose. Now it's okay, you can see that we are getting one single value, which is basically dot product between this matrix and this matrix. Now let's pick here my tf dot answer dot x multiplied by wt. Now this will return me a bigger matrix as you observe. The bigger matrix. That's the reason why in every equation we write y equals to, this is the resultant of y equals to wt dot x, whereas this is the resultant of y equals to x dot wt. So that's the reason why in the equation we never write like this, because every neuron take multiple input and it gives you one single output. So here in this case we are getting one single output, whereas in this case we are getting multiple arrays. It's basically representing 7 cross 7 array. So this is not required by the neuron. That is what I wanted to explain you through this example.
X or to both.
It is applied to your x value.
Because for
We
the
are doing an
case,
element by element matrix multiplication here. So we have to take summation along one common axis, and that axis here is 1. If you will take it to 0, your things will change to this. If you will take it as 1, then you will get the single output. Okay? Like along the rows and along the columns. Perform the element wise summation or matrix multiplication, keeping one axis aligned, then summation. So one axis will be aligned, one axis will not change itself, and the other will be summed together along the axis. Summation of elements, common axis. That's where we write here x is equals to 1.
without transpose also, it works with x is equal to 0 because anyways, 1 will be converted to row. I mean, considered as on axis 0. If without transpose in the 39 number 33, if we change axis to 0 and we don't do
Here if
transpose.
you will do, then it is okay. But this is not the resultant we are still looking, no?
Yeah, yeah.
This is not the result we are looking. If you will do 1, it will not, I mean, this is not a matrix multiplication, but if you will do it along 0, so basically you are saying that 1 is fixed. This time weights along the weights and the shape has changed.
Mm-hmm.
But it has to be x is equals to 1. For,
Okay.
so in that your shape is fixed to 7 cross 1 and 7 cross 1. Now let's try to understand a dense neural network, which is basically the resultant or output neural network of CNN as well. Using Keras package, we will learn about dense neural network. We will basically create a 3-layer neural network here, just for a basic understanding without any data and all. We will just create a default one. So for that, we will take a package TensorFlow dot Keras dot layers import dense from TensorFlow dot Keras dot models sequential from TensorFlow dot Keras dot optimizers import RMS prop. This is my dense neural network. Sequential connection with my neural network. Then we go with my optimizers of RMS prop. I will change it to Adam. Optimizers of classifier. Define build model. Model equals to sequential. Model dot add. Start by using dense. Units equals to 16. Activation function equals to rectified linear unit, and my input shape, which is equals to, you can provide here the number of features, let's say 5. What exactly the units indicates here? My units indicates here number of neurons. Activation function, this is given. Activation function is your ReLU, rectified linear unit, as I explained you all today. And input shape will be always require is equals to the shape of image. Now the shape of image could be like let's say 100 cross 100 cross 3, right? This will mean that the image shape is 100 cross 100 cross 3 dimensional. The shape of the image will be image height, image width, and dimensionality. Dimensionality will be, of course, will depend if you are working on a grayscale image or a what you will say, or a colored image. Colored image will have dimensionality as 3. This makes sense? This first layer is clear. Any question in this? Input layer, in the input shape will be used only in the input layer. Units is number of neuron in the first layer. It's written a number of neurons. Like in this example, how many number of neurons are there in the first layer? In this example, the first input layer has got 2 neurons. Second hidden layer has got 3 neurons, and output layer will be always about one neuron in this case. So that's what the units indicate. Okay, looks like there are no other further questions. Let's take here my next thing, which will be my hidden layer. Start by my hidden layer here. Hidden layer number 1. Let's take here my number of unit, which is equals to 32. Activation function equals to ReLU. Next, hidden layer number 2. In this case, my units will be equals to 64. So one rule you need to remember, that number of neurons, as we are moving towards further, it will continuously increase. So in the first neuron we have got, in the first input layer we have got 16 neurons. Hidden layer has got 32, 64, and so on. So as you will continue, as you will keep on adding multiple hidden layers, your number of neurons will keep on adding up here. When we have got here my output layer will be given by model dot add. We will add here in this case 1, and this will be updated to sigmoid. So the activation function name is good enough. You don't have to write anything here. This is the output layer for binary classification. Model.compile. Let's mention here my loss function name, which is given by binary underscore cross entropy optimizer equals to optimizer name is equals to we have to write here the loss function name, and optimizer name will be Adam, which we have imported at the top. So you can simply write here Adam directly. Next, metric. Metric will be basically the loss function again. Or no, sorry, here it will be accuracy, which will be the performance metric. Metric is something which has to be updated, and we will compare this metric to find our best model. So the optimizers will basically work to decrease the loss, and as the loss value will decrease, the accuracy will be we will be able to see the progress of the accuracy getting increased. That is what the importance of metric is. Return model. As of now, it looks good, but let's call build model to check if everything is fine or not. So now, if this works perfectly, that means there is no error. Get the model summary to get the details about the parameters. Parameters are the total combinations of these parameters are total number of weights and biases. These are all your total number of weights and biases, which would be obviously dependent upon how many number of neurons you are using in each layer. Okay. You can see that your input shape at the first had got 100 cross 100 cross 3, and that is what the same shape is getting changed to in all these layers that has been given to us. Okay, in model.compile model compiler, we take here the metric value, which is the check value or check statement for model performance. The resultant shape after every layer, like how your images are changing. Now, this last value will be dependent upon how many number of neurons has been taken. Like you can see 16 coming up, 32 coming up, 64 coming up. In the last layer, we have got one. Parameters that you see is the total combination of number of weights and number of biases, which can be calculated by 16 into dimensionality. 16 multiplied 3 will be 48
48.
plus 16 biases. You'll get
Oh,
64. Similarly, 32 multiplied by 16 plus 32. That will be the next layer. 64 multiplied by 32 plus 64. So this plus 64 indicates for the biases. Weights are basically calculated by the multiplication of input to the value. Now remember that the next in this part 16 outputs will come, which will go to 32 neurons. These 32 neurons will give me 32 output, which will go to the 64 neurons, and the 64 neurons will give you the 64 input, which will go to the final output layer to combine together to give you the final outputs. That's how it works. Hope that makes sense.
yes, yes. Understood. Thank you so much. Could relate this with yesterday's image that you showed for binary classification. Thank you.
Mm. Okay, now let's jump into the convolution neural network topic.